Hi guys, Mr. Hurley here, and today I've got something a little bit different to normal to show you. I've had a little bit of a random unexpected project to do, so I wanted to share it with you because I thought it was really cool. Now, we're coming up to the time where we're really wanting to start potty training our baby Finton, and we already have this potty to use for him. This is a hand-me-down potty, and it saves us having to buy a new one. And it's got this little table bench here that we can stick on there to give Finton, a little surface there. It's kind of like a strap. It straps him in so he can't just escape. So he stays in there until he does his business. And it gives him a table, so you could give him a little snack on there, or give him a toy. He can play with a car or something like that. And the way you attach that, if I can hold it all together, is it's got these little screws here, and the screw goes through one of those holes and it screws into the chair just like that. Okay. Now there's supposed to be another one for the other side, but it's missing. We were tossing up whether to throw out this potty because it didn't have that thing there, and that table can't be secured and it can't secure the baby in, so it's a bit useless without it. And then Mrs. Hurley, my wife Chloe, said, Ben, can you 3D print a replacement screw using your 3D printer? And I said, awesome, I'm totally going to do that. So that's what I've been working on. So I designed a screw. I actually used a different designing software called Fusion 360 to design the screw because it was a bit of a complicated shape. I wouldn't have the first idea where to begin designing such a complicated shape in SketchUp, but it's rather easy to do in Fusion 360. I've been learning through Fusion 360 lately, getting better at how to use it. It's a different mindset. You've got to think in a slightly different way. And but the day is coming where we will leave SketchUp behind and we'll move over to Fusion 360, and I think you'll get a bit of a sneak peek as to why. So here's the first screw that I made, and you can see that it's snapped. It just snapped across where the threads start. Now the reason why that snapped there is, number one, because this type of plastic PLA is not that strong to begin with, but also because of the way it was printed. Right? When we think about it, the 3D printer goes around and it prints it in layers, and it goes up and up and up and up. So every layer is sort of cross-cut across the object like that. So what's happened is just, when it was pulled a little bit too hard, one layer has just snapped apart like that. Okay, so the way that it's been printed like that, all in one piece, is really not ideal for strength. What we would really like is the layers to be going this way. Yeah. So if you think about it like a piece of wood, if you want to make a long piece of wood be strong, you're going to cut it so that the grain is following along the direction of the piece of wood. You're not going to cut it so you've got lots of short little grains here all side by side like that. It's just going to snap off where the grain of the wood is. And that's exactly what's happened here. It's kind of like the grain of the wood is running this way. That's the direction that the print layers are, and we want the grain of wood or the print layers to be going this way, so that there's full length of solid plastic layers going along this screw shaft like that. Okay, so let me show you how this looks in the modeling software in Fusion 360. Let's go to our desktop view here. That is the first bolt, I guess you could call it a bolt, that I designed, and it's all one piece. We can sort of swing around by moving this cube up here. All right, and you can see I've got the thread and everything and some nice rounded edges. Okay, so that one didn't work because it was printed all like that. We really can't just take this and flip it over onto its side and print it, because it would be resting on just a little straight line slice of this edge, and all this would be hanging out in thin air. So what I actually did is I broke it into two pieces. If I get rid of that one, and I made a separate head part of the screw, that's the part that you twist with your fingers, And I was able to do this really cool knurled effect around the edge like that. If I zoom in a little bit, it's got all these diamonds going all the way around. So just to give you a bit of grip, the original has like a cross piece on there you can really use to twist it and get a good grip. But this one, I couldn't do it with this one because I need that flat edge on the what's going to end up being the top to be able to have a nice flat surface to print on. So I decided to go with a knurled edges to get a grip to twist it on instead. So that's that, and you can see how there's a hole in the middle for the shaft to get super glued in later, and that hole has a nice little bit of slip fit tolerance to accept the screw thread shaft, which is, oh, I've got to activate the component. It's just a little bit fiddly, takes a bit of getting used to. And here is the screw thread shaft, and that's got enough distance to go through the head, and there's actually a little bit of just blank shaft. If I can get it. I might go back to the close-in view just for a second. You can see how there's like the threaded part here, and there's this other non-threaded part of the shaft down here. We don't really need this sort of sloping area here. I checked it out. That's not really important for the mechanical working of the screw. We really just need the thread here, blank there, and a nice surface on the head to screw down to. Okay, so going back to our desktop view. So there I've got my design. Now the problem with printing this is that I don't want to print it just like that as it is. If I print it that surface that just standing up like that, I could, but it's going to have the same problem as when I printed the first design, when it was all the layers going around and around and around like that. I'm going to have my layers going across like that. I don't want that. I want my layers going like this way. So I need to tip it onto its side. Trouble is I can't really do that because this is a round cylindrical object. If I tip it on its side, it's only going to have one line meeting point along like that. Okay, if you imagine if you take a bolt and tip it over, it's not going to have a flat surface to lay on. It's just going to be laying on one point going along its length. So we've got a neat trick. We can get around this in the slicing software. We can actually slice that screw thread in half. We can chop it right down the middle like that into two pieces, take the two pieces apart, and then lay them down, and we'll have a nice flat surface. So I'll show you how to do that. And if that didn't make sense, it'll make sense as I go through it. So I'll load the screw thread. I've already got my STL file ready to go. It's under 3D printing, miscellaneous, and screw shaft. There it is there. Now it's going to import it standing up like that. I don't want that. I want to select it, and I'm going to go down to this button we haven't used before. We're going to cut it. And I'm going to click it again to show up the options, and I'm going to, in the direction, I can do either an X plane cut or I can do a Y plane cut. That really doesn't matter which way I do it, it's going to achieve the same thing. But I think before I did it, yeah, if I do it this way, if I zoom in, there we go. You can see how this end of this thread is going to be sitting on top, and I think that's going to give it a nicer finish when it's 3D printed. This going this way is going to be the up and down direction. So if I do it the other way, I don't know, I just think that's going to work better. So I'll go with that way. So I go just select on the X plane. I don't want to keep both parts in place. I want them to come apart a bit, and then I'll go cut. And it just cuts into two pieces. How easy is that? Now all I need to do is I'm going to select this one. I'm going to go to the rotate tool, get my options back, and I'm going to do my surface to platform trick. I'm going to double click on this surface here, and that's going to put that surface on the bed for me. And if I think it's shift, yeah, if I shift and drag, it rotates my view. I'm just going to move this piece out of the way, and I'll go back to rotate, double click surface to platform, and I'll move it over just a little bit. Okay, and then all I need to do is I need to bring in the head of the screw, move it over to there, and then, oops, I need to be on rotate to do my rotating trick. Okay, and now I'm ready to do my settings. Now, what I also did is to make it a bit tougher, is I went into my settings. I always like to change the start points to use random start points to make the model a little bit, so it doesn't have those beads running up where the print head is always resting for a little bit and the layer goes down and it oozes out a little bit. Just makes it a bit tidier. What I did to make it tougher is I changed the infill to 50%. Okay, that doesn't mean that the inside of the print is now 50% full of material. I'm not sure exactly how they calculate it, but it just means that the hexagonal shape inside the part that's there to fill out the structure and give it strength, that's going to be a lot thicker and a lot tougher. And was it under perimeter? I did, and the thickness under shell count, I gave it 3 layers around all the edges instead of just 2, just to give the outside shell a bit more strength. Okay, and that's all I did. Apart from that, I did all my normal standard settings. Oh, except for one thing is I couldn't find my little file for cleaning up rims. So I gambled, and under additions, I actually, when I did it, this time I disabled the brims. I just had it to print just the part as it is on the bed. That was a little bit of a gamble, and I'm gonna see if that works. So what I did was I pressed no, and then the rest is the same as the standard settings that I went through on the website and in the last video, and click OK. Takes just a second. Okay, and it's a 1 hour and 13 minute print, and it's going to take 4 meters of filament. And then you export it as normal, chuck it in the printer, level your bed, and press print. Okay, so, and that I've already prepared that before, and you can see I've got my pieces there just so. So now I'm going to go over to the bench, and we're going to have a go at taking these apart and super gluing them together and reassembling it, gluing it all together, and seeing how it goes. Okay, so here I am at the bench. Now, I had meant to go through this at the time on camera, but I'm afraid I rather did a bit of a fast forward and did most of this already on, well, all of it really off camera. But I'll just go through the process of how it went. I've actually already taken off this one off of the print bed. You can see there's my 2 halves of the screw shaft. So those 2 go together like that. And this is designed to go inside there. Unfortunately, I kind of was a bit off on my calculations for the clearance for this hole is not big enough. So let's just get rid of that. And after a bunch of tests later, I finally found a measurement that works quite well. So this is, you can see that's a 2 halves, split in half shaft, which is our 14 millimeters, which I was going off for the screw shaft. And that goes in pretty nicely into this hole here. That end hole there is 0.65 millimeters bigger than the shaft. So that's 14 mil, that's 14.65, or at least that's what it was designed as in the software. You know, as they always come out a little bit differently. Pretty much everything gets made about 0.1 mil bigger on the outside or tighter on the inside of a hole. So those 2 go together pretty nice and tight. It's fairly well a press fit, and that's good because that holds the 2 pieces nice and snug on that side. And then what I did for the screw is, we pretend for a second that this thing with the holes in there, pretend that's the screw head, and pretend that it's the screw shaft. Is I got my trusty little super glue. I had this apart, super glued inside the hole on the surface. I super glued the flat edges of these 2 pieces together. Put some super glue around this outside radius, around the outside where it goes into the head, screw head, and then quickly just shove that in there. Am I doing the right one? Pretty sure it's that one. Yeah. It does have to be a little bit fairly well lined up for it to go in nicely. There we go. And then just press it down on the bench to get it nice and flat on that side. And then I got my F-clamp and I just clamped the ends sticking out together like that. As you can see, that's going to snug up the two halves of that shaft just nicely. You can probably see, I'll get it just right. You can see that's clamping down the two halves to press them together to get the glue surfaces together. So that's how the glue up process went. And here is the finished result. That's the one where I got all the measurements right. I made my hole in there 0.65 millimeters bigger than the shaft. The two halves of the thread are nice and clamped tight shut, so that's looking pretty good. It looks quite rough because there was quite a bit of filing involved. I found my file, hooray! And I found that I just had to, you can probably maybe see a bit of the glue beading up over here. I didn't worry about over there, but in and around all of these threads I had to go through and just sand, keep saying sand, I mean file. I had to file down all the glue that squirted out the edges and get that to be nice and neat and tidy on both ends. And then when I went to test it to put it in the hole of the arm on the potty, it was too tight to screw in, and I was wondering what that was. So I thought it's probably just the outside diameter. So I measured the outside like that on my calipers. I found it was about 0.1 of a millimeter wider than on the original one that I did. The original one that snapped, it fit really, really well, and it screwed in just really nicely. And this one was only 0.1 mil wider, but so I took my file and I just filed just across the surface all the way around like that. I gave it a good couple of goes around. I'm just sort of pretending now. I actually went quite rough and tried to take that down a fair whack. And that seemed to work. It worked really well. It goes in now. It's quite snug still, but it goes all the way in and it screws nice and tight, and it's very secure. I was a little bit worried. I was hoping that it wasn't that the threads on this one are much more precise. You might be able to see there's very neat square edges. If I can get a good focus, there's much neater, squarer edges to these threads than the other one. The other one that was printed this way, the bottom sides of the threads were drooping down because they were unsupported. So I was wondering if the shapes of the threads might have been making a big difference, but it seemed that after I just filed it just all the way around like that, it really did the trick. So I guess the takeaway from that is that just to keep in mind, to really remember that if you're needing to make something to a particular dimension, you really want to make design your product in your design software about 0.1 mil smaller than what you want it to end up, because things are on the Flash Forge Inventor 2 generally come out about 0.1 millimeter wider or bigger than what you design them. So there you go. I really like the knurled edges that I was able to get around there. Maybe I'll do when we get into Fusion 360, we can go into cool things like that as well. So there we have it. So there you go. Now I've got a handy little homemade plastic screw. There we go, which holds on the tray to our potty nice and securely, holds the baby in so we can't escape. And now this potty that we were thinking of throwing away is now perfectly usable, and it's saved us a lot of money. So I think that's really the big strength of 3D printing. It's really not fast enough to do lots of batch manufacturing, if you're wanting to, you know, like make something to sell and make money from, you really wouldn't 3D print lots of copies of things for selling them directly like that. It's just far too slow. You don't get enough quantity of products. You'd be much better off doing something like injection molding. It's a much faster process. But 3D printing is really ideal for doing prototyping, for just testing out a design to see how it goes, and then go to batch manufacturing like injection molding, or for, in this situation, using it to make just a one-off little item or thing that you need to, you know. So I had a potty that I couldn't use, that was just junk to me, if I didn't have the 3D printer to make that replacement screw. So things that are, you know, that you can't just go to a shop and buy. If you've got a little gadget that just needs a little plastic clip or a little plastic cover. I mean, like I was half thinking about my lawnmower. Its air filter cover, housing cover that holds the air filter in there is fallen off and got lost, and it's an Aldi lawnmower, and I don't think you can just go and buy just the air filter cover piece of plastic for that. So that's on one of my things to maybe try one day, to see if I can 3D print that random part that you couldn't otherwise buy. So that's really for me what 3D printing at the moment is all about, and that's why I thought I was pretty excited to get a good idea for a project that was really suited to 3D printing. Okay, so I hope you guys enjoyed seeing about that, and catch you in the next video. Bye.